Hello everyone, it's Mr. Garrett here, coming to you from my secret underground laboratory. And today, we're going to take a closer look at mass. Well, what is mass? Mass is the total amount of matter inside an object or a person. So for instance, the mass, solid, liquid, and gas, that makes me up weighs approximately 223 pounds, give or take, based on the amount of food, sleep, exercise that I get in a day. But today we're going to be taking a look at the mass found in a piece of construction paper or cardstock, ice cubes, as well as water and sugar combined. So go ahead and pull up your conservation of mass chart and we will go ahead and begin. You can pause the video now. All right, everyone, now that you have that chart pulled up, as you can see, the first thing that we're going to find the starting mass for is this piece of construction paper. So what we're going to do is we're going to take this construction paper, this nice flat piece of cardstock, and lay it on our scale. Now, I know it's going to be hard for you guys to read the scale. I'll go ahead and read out the numbers to you so that way you guys can record them on your chart. So the starting mass of this piece of construction paper is 5.4 G. Well, what is G? Graham crackers? Gorillas? No, G stands for grams. Grams is a unit of measurement that we can use to measure the amount of mass an object has, as well as kilograms, pounds, liters. But today, we're going to be measuring in grams because the objects we're measuring are relatively small. So go ahead and record the starting mass of the construction paper, which weighs 5.4 grams. You can pause the video and record that now. Okay, now that you've recorded that, we're going to weigh the starting mass of 2 ice cubes. Now, in order to do that, I'm going to take a cup here and measure the starting mass of the 2 ice cubes. So I'm going to get my handy dandy tongs here and pull out 2 ice cubes to put in the cup. 2 ice cubes to put in the cup. Okay, we'll put the lid back on there so all of the water in here does not evaporate. More about evaporation later. Okay, we're going to take the 2 ice cubes in the cup and place it here on the scale. Okay, the measurement reads 21.5 grams. 21.5 grams. So pause the video, record 21.5 grams on your starting mass for the 2 ice cubes. Okay, now that you've recorded the starting mass of the 2 ice cubes, I'm going to remove those ice cubes and set them aside. Now, the last thing that we need to measure is the water and sugar combined. Now, water, I'm going to take a little bit of water and pour in the cup that says, water. Okay. And then I'm going to take some sugar and pour in the cup that says sugar. Looks like the sugar is hardened a little bit. I need to break it up. That should do it. Okay, poured some sugar and some water together. I'm now going to take these 2 items, sugar being a solid, water being a liquid, and measure them together. And we're going to record the total starting mass for the sugar and water, which weighs 52.6 grams. So go ahead and record 52.6 grams. You can pause the video now. Okay, now that you've recorded the starting mass for the sugar and water, we can go ahead and remove those from the scale. And now I'm going to ask you at home to make a prediction. So if you look at the next column, on your conservation of mass chart, you'll see that we're going to predict the mass after we change the objects that we just measured. So the first thing we're going to do is take the 2 ice cubes in the cup, they're still in there, and I am going to heat up the ice cubes. Now, we have talked about this. When I heat up the ice cubes, it's going to cause those ice cubes to melt, correct, into water. But actually, what is happening is the heat from the blow dryer is causing all of those tiny little atoms or molecules inside the ice cubes, which is currently a solid, to heat up. That energy is causing them to move quicker and quicker and quicker till they start to separate, and then the ice cube will turn into a liquid. Okay, so I'm now going to apply heat to the ice cubes.
A few minutes later.
Okay, the ice cubes are now melted. So before we stick the ice cubes back on the scale, I want you guys to go ahead and predict, what do you think the mass will be after I have melted the ice cubes? Go ahead and pause the video and record that now. Okay, now that you've recorded the predicted mass of the ice cubes after they've melted, I'm now going to ask you to do the same thing for the construction paper. So we're going to take the cardstock construction paper and I'm going to crumple it up, pack it really tight and close together. So if you can see there, it's much, much smaller. And now I'm going to ask you to record the total mass, predicted mass of the construction paper after I've crumpled it up. Pause the video and record it now. Okay, now that you've predicted the mass of the construction paper and ice cubes, after I've melted the ice cubes and crumpled up the construction paper, I am now going to take the water and the sugar and mix them together. So when I pour the water into the sugar and stir it up, the sugar will actually melt. It will dissolve into the water. Now, bonus term here, when we have a solid dissolve into a liquid and we mix them together, that is called a solution. A solution. So now we have our solution of water and sugar mixed together. We're going to weigh that, but before we do, I want you to predict what you think the total mass is of our solution of water and sugar mixed together. Go ahead and pause the video and record it now. Okay, now that you've recorded all 3 predictions, we're going to go ahead and weigh their mass after we've changed their state. So let's start with the melted ice cubes. Okay, what did you predict? Do you think the ice cubes are going to weigh more? Or do you think they're going to weigh less? Or maybe you think they're going to stay the same? I can't wait to see your results. So here we go. Let's go ahead and weigh the ice cubes after we've melted them. And they weigh 21.5 grams. 21.5 grams. Go ahead and record 21.5 grams as the actual mass after change for your 2 ice cubes. What did you notice? Did you notice that the weight stayed the same? Interesting. Just because I melted the ice cubes and turned them into a liquid did not change the total mass. Now, let's take a look at the crumpled up construction paper. Do we expect the same results? Let's see. The construction paper weighs 5.1 grams. 5.1 grams. That was the same mass that it started out being when it was unfolded and flat. And I crumpled it together. But just because I changed its looks and crumpled it up, the mass did not change. Interesting. All right, I'm going to give you a chance to go ahead and change your prediction for your sugar and water solution. So if you predicted that it would weigh more, or if you predicted that it weighed less, or maybe you predicted that it weighed the same. If you would like to change that, you can do so now. So go ahead and pause the video and do that now. Okay, maybe you decided not to change your prediction. Okay, maybe you think it's going to weigh more, maybe you think it's going to weigh less, maybe you think it's going to weigh the same. But let's go ahead and find out. The sugar and water solution mixed together weighs 52.6 grams. 52.6 grams. Sure enough, when I mix the water and the sugar together, it weighs the same exact amount, has the same exact mass as it did when we first started. Amazing, amazing. Okay, now that you have seen the 3 conservation of mass demonstrations, I now need you to answer the short paragraph. I want 3 sentences explaining what happens to the mass of matter when it undergoes a change. I want you to describe to me what happens to the total mass of matter when it undergoes a physical change. So that could be a solid going to a liquid going to a gas coming back down to a solid. What happens to the total mass of matter when it undergoes a change? 2 or 3 sentences below. Go ahead and answer that now. You may pause the video. All right, welcome back everyone. Hopefully you got all of that information recorded on your conservation of mass table there. Hopefully you answered the final question in 2 to 3 sentences. I look forward to seeing what you guys learned about the conservation of mass and what happens to the mass of matter when it undergoes a change. If you guys have any more questions or you have any ideas for future experiments, please message me and let me know. All right, guys, we will look forward to seeing you soon. This is Mr. Garrett coming to you from my secret underground laboratory. I can't wait to see you guys next time. Goodbye.